This handbook describes the various environmental conditions affecting human survival and describes isolated personnel. Isolated personnel, activities necessary to survive during successful evasion or isolating events leading to successful recovery. It is the fundamental reference document providing guidance for any USAF service member who has the potential to become isolated. Deviations require sound judgment and careful consideration. This publication provides considerations to be used in planning and execution for effective mission accomplishment of formal USAF survival, evasion, resistance, and escape, SERE, training, environmentally specific SERE training, and combat survival continuation training programs. The tactics, techniques, and procedures in this publication are recognized best practices presenting a solid foundation to assist USAF service members to maintain life and return with honor from isolating events. Except for the water they drink and the oxygen they breathe, IP must meet their physical needs through the intake of food. This chapter will explore the relationship of proper nutrition to physical and mental efficiency. It is extremely important that IP maintain a proper diet at all times. A nutritionally sound body stands a much better chance of surviving. Improper diet over a long period of time may lead to a lack of stamina, slower reactions, lower resistance to illness, and reduced mental alertness, all of which can cost IP their lives in a survival situation. Knowledge of the body's nutritional requirements will help IP select foods to supplement their rations. IP expend much more energy during isolating situations, especially while evading or traveling, than they would in the course of their normal everyday jobs and life. Basal metabolism is the amount of energy expended by the body when it is in a resting state. The rate of basal metabolism will vary slightly with regard to the sex, age, weight, height, and race of a person. The basic energy expended or number of calories consumed by the hour will change as a person's activity level changes. For example, a person who is simply sitting in a warm shelter may consume anywhere from 20 to 100 calories per hour, while that same person in an evasion situation maneuvering through thick undergrowth with a heavy pack would expend a greater amount of energy. In an isolating event, proper food can make the difference between success and failure. The three major categories of food are carbohydrates, fats, and proteins. Vitamins and minerals are also important as they keep certain essential body processes in good working order. It is also necessary for an IP to maintain proper water and salt levels in their bodies, as they aid in the body's ability to break down and use food, as well as preventing certain heat and cold disorders. Carbohydrates are composed of very simple molecules which are easily digested. Carbohydrates lose little of their energy to the process of digestion and are therefore efficient energy suppliers. Because carbohydrates supply easily used energy, many nutritionists recommend that, if possible, individuals should try to use them for up to half of their calorie intake. Obviously, since an IP in an isolating event is likely to expend more than the individual faced with a normal day, they should increase their intake of carbohydrates to 60–70% of their total calories from carbohydrates. It is important that IPs, if possible, eat before, during, and after the isolating event to make sure that they will have enough energy in the muscles for the next obstacle or task they must overcome or accomplish. Examples of carbohydrates include starches, sugars, and cellulose. These can be found in fruits, vegetables, candy, milk, cereals, legumes, and baked goods. Cellulose cannot be digested by humans, but it does provide needed roughage for the diet. Fats are more complex than carbohydrates. The energy contained in fats is released slower than the energy in carbohydrates. As a result, it is a longer-lasting form of energy. Fats supply certain fat-soluble vitamins. Sources of these fats and vitamins include butter, cheese, oils, nuts, egg yolks, margarine, and animal fats. If IP eat fats before sleeping, they will be warmer during sleep. If fats aren't included in the diet of IP, they can become run down and irritable. This can lead to both physical and psychological breakdown. The digestive process breaks protein down into various amino acids. These amino acids are formed into new body tissue protein, such as muscles. Some protein gives the body the exact amino acids required to rebuild itself. These proteins are referred to as complete. Protein that lacks one or more of these essential amino acids is referred to as incomplete. Incomplete protein examples include cheese, milk, cereal grains, and legumes. Incomplete protein, when eaten in combination with milk and beans for example, can supply an assortment of amino acids needed by the body. Some complete protein is found in fish, meat, poultry, and blood. No matter which type of protein is consumed, it will contain the most complex molecules of any food type listed. If possible, a recommended daily allowance of 2.5 to 3 ounces complete protein should be consumed by each IP each day. If only incomplete protein is available, 2, 3, or even 4 types of foods may need to be eaten in combination so enough amino acids are combined to form complete protein. If amino acids are introduced into the body in a large amount and some of them are not used for the rebuilding of muscle, they are changed into fuel or stored in the body as fat. Because protein contains the more complex molecules, over fats and carbohydrates, protein supplies energy after other forms of energy have been used up. A lack of protein causes malnutrition, skin and hair disorders, as well as muscle atrophy. Vitamins occur in small quantities in many foods, and are essential for normal growth and health. Their chief function is to regulate the body processes. Vitamins can generally be placed into 2 groups, fat-soluble and water-soluble. The body only stores slight amounts of the water-soluble type. During a long isolating event where a routinely balanced diet is not available, IP must overcome food aversions and eat as much of a variety of vitamin-rich foods as possible. Often one or more of the 4 basic food groups, meat, fish, poultry, vegetables and fruits, grain and cereal, milk and milk products, are not available in the form of familiar foods, and vitamin deficiencies such as beriberi or scurvy result. If IP can overcome aversions to local foods high in vitamins, these diseases as well as signs and symptoms such as depression and irritability can be warded off. Adequate minerals can also be provided by a balanced diet. Minerals build or repair the skeletal system and regulate normal body functions. Minerals needed by the body include iodine, calcium, iron, and salt. A lack of minerals can cause problems with muscle coordination, nerves, water retention, and the ability to form or maintain healthy red blood cells. For IP to maintain their efficiency due to the extremes of an isolating event and work involved, the following number of calories per day is recommended. These figures will vary because of individual differences in basal metabolism, weight, etc. During warm weather, IP should consume anywhere from 3,000 to 5,000 calories per day. In cold weather, the calorie intake should rise from 4,000 to 6,000 calories per day. A familiarity with the calorie and fat amounts in foods is important for IP to meet their nutritional needs. For example, it would take quite a few mussels and dandelion greens to meet those requirements. IP should attempt to be familiar enough with foods that they can select or find foods that provide a high calorie intake. IP should also be familiar with the number of calories supplied by the food and issued rations. In most situations, rations will have to be supplemented with other foods procured by IP. If possible, IP should limit their activities to save energy. Rationing food is a good idea because IP never know when their survival ordeal will end. They should eat when they can, keeping in mind that they should maintain at least a minimum calorie intake to satisfy their basic activity needs. Caloric and fat values of selected foods are shown in the chart, and unless otherwise specified, the foods listed are raw. Depending on how IP cook the food, the usable food value can be increased or decreased. IP should be able to find something to eat wherever they are. One of the best places to find food is along the seacoast, between the high and low water mark. Other likely spots are the areas between the beach and the coral reef, marshes, mudflats, or mangrove swamps where a river flows into the ocean or into a larger river, riverbanks, inland waterholes, shores of ponds and lakes, margins of forests, natural meadows, protected mountain slopes. and abandoned cultivated fields are also good food sources. Rations have been developed especially to provide some of the proper sustenance needed. When eaten as directed on the package, they will keep IP relatively nourished. If enough other food can be found, rations should be conserved for emergency use. Consideration must be given to available food and water and how long the isolating event may last. Environmental conditions must also be considered. If the IP are in a cold environment, more of the proper food will be required to provide necessary body heat. Available food must be rationed based on the estimated time which will elapse before recovery and being able to supplement issued rations with natural foods. If IP should seek help, each traveler should be giving twice as much food as those staying behind. The IP resting at the encampment and those seeking help will stay in about the same physical condition for about the same length of time. Avoid dry, starchy, and highly salted foods and meats if less than a quart of water is available per day. Keep in mind that eating increases thirst. For water conservation, the best foods to eat are those with high carbohydrate content, such as hard candy and fruit. All physical activity requires additional food and water. When physical activity is being performed, the IP must increase food and water consumption to maintain physical efficiency. If food is available, it is acceptable to eat several times throughout the day. It is preferable to have at least 2 meals a day, with one meal being hot. Cooking usually makes food safer, more digestible, and palatable. The time spent cooking will provide a good rest period. On the other hand, some foods are not palatable unless eaten raw. Native foods may be more appetizing if they are eaten by themselves. In many countries, vegetables are often contaminated by feces, animal or human, which the natives use as fertilizer. Dysentery is transmitted in this way. If possible, the IP should try to select and prepare their own meals. If necessary to avoid offending the native peoples, indicate that religious beliefs or taboos require self-preparation of food. Learn to overcome food aversions. Foods that may not look good are often a part of the locals. Regular diet. Wild foods are high in mineral and vitamin content. With a few exceptions, all animals are edible when freshly killed. Avoid strange-looking fish and fish with flesh that remains indented when depressed, as it is possibly spoiled and should not be eaten. With proper knowledge, pre-mission study, EVCs, etc., and the ability to overcome food aversions, IP can eat and sustain themselves in strange or hostile environments. Animal food gives the most food value per pound. Anything that creeps, crawls, swims, or flies is a possible source of food. People eat grasshoppers, hairless caterpillars, wood-boring beetle larvae and pupae, and eggs, spider bodies, and termites. Such insects are high in fat, carbohydrates, and should be cooked until dried. Everyone has probably eaten insects contained in flour, cornmeal, rice, beans, fruits, and greens in their daily foods. To become successful in hunting, IP must go through a behavioral change and reorganize personal priorities. This means the one and only goal for the present is to kill an animal to eat. To kill this animal, the IP must mentally become a predator. The IP must be willing and prepared to forego stress in order to hunt down and kill an animal. Because of the type of weapons IP are likely to have, it will be necessary to get very close to the animal to immobilize or kill it. This is going to require large amounts of stealth and cunning. Knowledge of the animal being hunted is also very important. If in an unfamiliar area, IP may learn much about the animal life of the area by studying signs such as trails, droppings, and bedding areas. IP should understand the general characteristics of the animals in the area. The size of the tracks will give a good idea of the size of the animal. The depth of the tracks will indicate the weight of the animal. Animal droppings can tell the IP much. For example, if it is still warm or slimy, it was made very recently. If there is a large amount scattered around the area, it could well be a feeding or bedding area. The droppings may also indicate what the animal feeds on. Carnivores often have hair and bone in their droppings. Herbivores have coarse portions of the plants they have eaten. Many animals mark their territory by urinating or scraping areas on the ground or trees. These signs could indicate good trap or ambush sites. By following those signs, tracks, droppings, etc., IP may learn about the feeding, watering, and resting areas of the animals they are hunting. Well-worn trails will often lead to the animal's watering place. Having made a careful study of all the signs of the animal, the IP is in a much better position to capture it, whether electing to stalk, trap, snare, or lie in wait to shoot it. If IP elect to hunt, there are some basic techniques which will be helpful and improve chances of success. Wild animals rely entirely upon their senses for their preservation. These senses are smell, vision, and hearing. Humans have lost the keenness of some of their senses like smelling, hearing, etc. To overcome this loss, humans have the ability to reason. As an example, some animals have a fantastic sense of smell, but this can be overcome by approaching the quarry from a downwind direction. The best times to hunt are at dawn and dusk as animals are either leaving or returning to their bedding areas. Both diurnal and nocturnal animals are active at this time. There are 5 basic methods of hunting. Ambush is the best method for inexperienced hunters as it involves less skill. The main principle of this method is to wait along a well-used game trail until the quarry approaches within killing range. Morning and evening are usually the best times to still hunt. Care should be taken not to disturb the area, always wait downwind. Patience and self-control are necessary to remain motionless for long periods of time. Stalking refers to the stealthily approach toward game. This method is normally used when an animal had been sighted and the IP proceeds to close the distance using all available cover. Stalking must be done slowly so that minimum noise is made. Quick movement is easily detected by the animal. Always approach from the downwind side and move when the animal's head is down eating, drinking, or looking in another direction. The same techniques are used in blind stalking as in regular stalking, the main difference being that the IP is stalking a position where the animal is expected to be while the animal is not in sight. Tracking is very difficult unless conditions are ideal. This method involves reading all of the signs left behind by the animal, interpreting what the animal is doing, and how it can best be killed. The most common signs are trails, beds, urine, droppings, blood, tracks, and feeding signs. Some wild animals can be scared or driven in a direction where other IP or traps have been set. This method is normally used where the animals can be funneled. A valley or canyon is a good place to make a drive. More than one person is usually necessary to make a drive. Small predators may be called in by imitating an injured animal. Ducks and geese can be attracted by imitating their feeding calls. These noises can be made by sucking on the hand, blowing on a blade of grass or paper, sucking the lip, or using specially designed devices. IP should not call animals unless they know what they are doing, as strange noises may spook the animal. It is difficult to kill animals of any size without using some type of tool or weapon. As our technology has increased in complexity, so have our killing tools. If a firearm, spear, or club, etc., is available, a basic knowledge of shooting and hunting techniques is necessary. One of the limiting factors in the use of firearms is the amount of ammunition on hand. Therefore, IP cannot afford to waste ammunition on moving game or game which is beyond the effective range of the firearm being used. Wait for a pause in the animal's motions. The shot must be placed in a vital area with any firearm. Aim for the brain, spine, lungs, or heart. A hit in these areas is usually fatal. A full-jacketed bullet often won't immediately down a larger animal hit in a vital area such as the lungs or heart. The alternative to losing the animal is tracking it to where it falls. Often it is better to wait a while before pursuing the animal. If not pursued, the animal may lie down and stiffen or perhaps bleed to death. Follow the blood trail to where the animal has gone down and kill it if it is still alive. Even though ammunition might be limited, small animals may be more productive than large ones. Although they present smaller targets and have less meat, they were less wary, more numerous, and travel less distance to escape if wounded. A large amount of edible meat on small animals can be destroyed from a bullet wound. On rodents, most of the meat is on the hindquarters and front quarters. On birds, most of the meat is in the breast and legs. IP should try to hit a vital spot that spoils the least amount of meat. Night hunting is usually best, since most animals move at night. A flashlight or torch may be used to shine in the animal's eyes. It will be partly blinded by the light and IP can get much closer than in the daytime. If a gun is not available, the animal can be killed with either a club or a sharpened stick used as a spear. Remember that large animals, when wounded, cornered, or with their young, can be dangerous. Be sure the animal is dead, not just wounded, unconscious, or playing possum. Animals usually die with their eyes open and glazed over. Poke all dead animals in the eye with a long sharp stick before approaching them. Small freshwater turtles can often be found sunning themselves along rivers and lake shores. If they dash into shallow water, they can still be procured with nets, clubs, etc. IP should be careful of the mouth and claws. Frogs and snakes also sun and feed along streams. Use both hands to catch a frog, one to attract it and keep it busy while grabbing it with the other. Bright cloth on a fish hook also works. All snakes are edible and can be killed with a long stick, but the IP should consider the potential danger of being bitten versus needing food. Both marine and dry land lizards are edible. A noose, small fish hook baited with a bright cloth lure, slingshot, or club can be used. A slingshot can be made with a forked stick and the elastic from the parachute pack or surgical tubing found in some survival medical kits. With practice, the slingshot can be very effective for killing small animals. Snaring and trapping animals are ways IP can procure animal food to supplement issued rations. Since small animals are usually more abundant than large animals, they will probably be the IP's main source of food. Snares should be set out on a 15:1 ratio. 15 snares should be set out for every one animal expected to be caught. Using traps and snares are more advantageous than going out on foot and physically hunting the animal. The most important advantage is that traps work 24 hours a day without assistance from the hunter. A large area can be effectively trapped with the possibility of catching many animals within the same period of time. IP, generally, use much less energy maintaining a trap line than is used by hunting. This means less food is required because less energy is expended. The traps or snares should be set in areas where the game is known to live or travel. Look for signs such as tracks, droppings, feeding signs, or actual sightings of the animal. If snares are used, they should be set up to catch the animal around the neck. Therefore, the loop must allow the head to pass through but not the body. Loops will vary in size from one animal to another. When placing snares, try to find a narrow area of the game trail where the animal has no choice but to enter the loop. If a narrow area cannot be found, brush or other obstacles can be arranged to funnel the animal into the snare. Do not overdo the funneling. Use as little as possible. Avoid disturbing the natural surroundings if possible. Do not walk on game trails, but approach 90 degrees to the trail, set the snare, and back away. Snares may also be set over holes or burrows. All snares and traps should be set during the midday because most animals are nocturnal in nature. Check snares and traps twice daily. If possible, check in the morning after the sun rises and prior to sunset. Checking the snares should be made from a distance so any animals moving at the time of checking will not be disturbed or frightened away. 1. A free sliding noose, when tightened around the neck, will restrict circulation of air and blood. The materials should be strong enough to hold the animal. For example, suspension line, string, wire, cable, or rawhide. 2. Mangle traps use a weight which is suspended over the animal's trail or over bait. When the animal trips the trigger, the weight, log, will descend and mangle the animal. 3. Any means of holding the animal and detaining its progress would be considered a hold-type trap. The Apache foot snare is an example of a hold-type trap. It is used for large browsers and grazers like deer. It should be located along game trails where an obstruction, such as a log, blocks the trail. When animals jump over this obstruction, a very shallow depression is formed where their hooves land. The Apache foot snare should be placed at this depression. The box trap for birds is another example of hold-type traps. Box trap The simple loop is the quickest snare to construct. All snares and traps should be simple in construction with as few moving parts as possible. This loop can be constructed from any type of bare wire, suspension line, inner core, vines, long strips of green bark, clothing strips or belt, and any other material that will not break under the strain of holding the animal. If wire is being used for snares, a figure 8 or locking loop should be used. Once tightened around the animal, the wire is locked into place by the figure 8, which prevents the loop from opening again. A simple loop snare is generally placed in the opening of a den, with the end of the snare anchored to a stake or similar object. The simple loop snare can also be used when making a squirrel pole or with some types of trigger devices. Squirrel pole. Triggers may be used with traps. The purpose of the trigger is to set the device in motion, which will eventually strangle, mangle, or hold the animal. There are many triggers. Some of the more common ones include: use a 2-pin toggle with a counterweight for small to medium-sized animals, and lift out of the reach of predators. Figure 8 with wire snare for small mammals and rodents. Canadian ace for predators such as bobcat, coyote, etc. The 3-pin toggle with deadfall is used for medium to large animals. Medium and large animals can be captured using deadfalls, but this type of trap is recommended only when big game exists in large quantities to justify the great expense of time and effort spent in constructing the trap. The twitch-up snare incorporates a simple loop for small animals. When the animal is caught, the sapling jerks it up into the air and keeps the carcass out of the reach of predators. This type of snare may not work well in cold climates, since the bent sapling will freeze in position and not spring up when released. A possible cold weather environment modification to this trap is to use a counterweight instead of bent sapling. A long forked stick can be used as a twist stick to procure ground squirrels, rabbits, etc. A den that has signs of activity must be located. Using the long forked stick, probe the hole with the forked end until something soft is felt. Twisting the stick will entangle the animal's hide in the stick and the animal can be extracted. There are several ways to catch birds. Birds can be caught with a gill net. The net should be set up at night vertically to the ground in some natural flyway, such as an opening in dense foliage. A small gill net on a wooden frame with a disjointed stick for a trigger can also be used. A gill net can be made by using inner core from parachute suspension line. Birds can be caught on baited fish hooks or simple slipping loop snares. A bird's nest can be a source of food. All bird eggs are edible when fresh. Large wading birds such as cranes and herons often nest in mangrove swamps or in high trees near water. During molting season, birds cannot fly because of the loss of their flight feathers, therefore they can be captured by clubbing or netting. Birds can be also caught in an ojibwa snare. This snare is made by cutting a 1 or 2 inch thick sapling at a height of 4.5 to 5 feet above the ground. A springy branch is whittled flat at the butt end and a rectangular hole is cut through the flattened end. One end of a stick, 15 inches long, is then whittled to fit slightly loose in the hole, and the top corner of the whittled end is rounded off so the stick will easily drop away from the hole. The branch is then tied by its butt end to the top of the sapling. A length of inner core from suspension line is tied to the bottom end of the branch and the branch is bent into a bow with the line passing through the hole in the butt end. A knot is tied in the line and the 15-inch stick is placed in the hole to lock the line in place. Just behind the knot, an 8-inch loop is made at the end of the line and laid out on the 15-inch stick, spread out as well as possible. A piece of bait is placed on top of the sapling, and when a bird comes to settle on the 15-inch stick, the stick drops from the hole, causing the loop to tighten around the bird's legs. When many birds frequent a particular type of bush, some simple loop snares may be set up throughout the bush. Make the snares as large as necessary for the particular type of birds that come to perch, feed, or roost there. In wild, wooded areas, many larger species of birds such as spruce grouse, which has merited the name fool's hen, and ptarmigan may be approached and killed with a stick with little trouble. It often sits on lower branches of trees and may be caught with a long stick with a loop at the end. IP may turn to insects as a food source and may overcome food aversions as a result. When food is limited and insects are available, they can become a valuable food source. In some places, locusts and grasshoppers, cicadas, and crickets are eaten regularly, occasionally termites, ants, and a few species of stonefly larvae are consumed. Big beetles such as the Goliath beetle of Africa, the giant water beetles, and the big longhorns are relished the world over. Clusters, like those of the snipefly Athrix, that overhang the water, and the Windrosa brinefly puparia are eaten. Aquatic water bugs of Mexico are grown especially for food. All stages of growth can be eaten, including the eggs, but the large insects must be cooked to kill internal parasites. Termites and white ants are also an important food source. Strangely enough, these are closely related to cockroaches. The reason they are eaten so extensively in Africa is the fact that they occur in vast numbers and are easily collected both from their nests and during flight. Many Native Americans made a habit of eating the large carpenter ants that are sometimes pests in many households. These ants were eaten both raw and cooked. Although the practice of eating them has not entirely disappeared, ants do not form an essential part of the diet of any of the inhabitants of this country. Honey ants, leaf-cutting or umbrella ants, and others are edible in all stages, both raw and cooked. It is natural that caterpillars, the larvae of moths and butterflies, form a very substantial part of the food of primitive peoples because they are large size and abundant. Caterpillars with hairs should be avoided. If eaten, the hairs may become lodged in the throat, causing irritation or infection. Today it is known that insects have nutritional or medicinal value. The praying mantis, for example, contains 58% protein, 12% fat, 3% ash, vitamin B complex, and vitamin A. The insect cytoskeleton is an interesting compound of sugar and amino acids. Bee larvae, locusts, dragonflies, bumblebees, cockroaches and locust grasshoppers, golden June beetles, crickets, wasp larvae, and silkworm larvae are all used for food. Insects should have any stinging apparatus, legs, wings, and heads, removed before they were eaten. Insects have been used as a food source for thousands of years and will undoubtedly continue to be used. If IP cannot overcome their aversion to insects as a food source, they will miss out on a valuable and plentiful supply of food. Fishing is one way to obtain food throughout the year wherever water is found. Figure 17-18. There are many ways to catch fish, which include hook and line, gill nets, poisons, traps, and spearing. If an emergency fishing kit is available, there will be a hook and line in it. However, if a kit is not available, a hook and line will have to be procured or improvised. Hooks can be made from wire or carved from bone or wood. The line can be made by unraveling a parachute suspension line or by twisting threads from clothing or plant fibers. A piece of wire between the fishing line and the hook will help prevent the fish from biting through the line. Insects, smaller fish, shellfish, worms, or meat can be used as bait. Bait can be selected by observing what the fish are eating. Artificial lures can be made from pieces of brightly colored cloth, feathers, or bits of bright metal or foil tied to a hook. If the fish will not take the bait, try to snag or hook them in any part of the body as they swim by. In fresh water, the deepest water is usually the best place to fish. In shallow streams, the best places are pools below falls, at the foot of rapids, or behind rocks. The best time to fish is usually early morning or late evening. Sometimes fishing is best at night, especially in moonlight or if a light is available to attract the fish. IP should be patient and fish at different depths in all kinds of water. Fishing at different times of the day and changing bait is often rewarding. The most effective fishing method is a net because it will catch fish without having to be attended. If a gill net is used, stones can be used for anchors and wood for floats. The net should be set at a slight angle to the current in order to clear itself of any floating refuse that comes down the stream. The net should be checked at least twice daily. A net with poles attached to each end works effectively if moved up or down the stream as rapidly as possible while moving stones and threshing the bottom or edges of the stream banks. The net should be checked every few moments so the fish cannot escape, making a gill net with shuttle and spacer. shrimp, prawns, live on or near the sea bottom and may be scraped up or lured to the surface with light at night. A hand net made from parachute cloth or other material is excellent for catching shrimp. Lobsters are creeping crustaceans found on or near the sea bottom. A lobster trap, jig, baited hook, or dip net can be used to catch lobster. Crabs will creep, climb, and burrow and are easily caught in shallow water with a dip net or in traps baited with fish heads or animal viscera. Fish traps are very useful for catching both freshwater and saltwater fish, especially those that move in schools. In lakes or large streams, fish tend to approach the banks and shallows in the morning and evening. Sea fish, traveling in large schools, regularly approach the shore with the incoming tide, often moving parallel to the shore guided by obstruction in the water. A fish trap is basically an enclosure with a blind opening where two fence-like walls extend out, like a funnel, from the entrance. The time and effort put into building a fish trap should depend on the need for food and the length of time IP plan to stay in one spot. The trap location should be selected at high tide and the trap built at low tide. 1 to 2 hours of work should be sufficient to hold the trap. Consider the location, and try to adapt natural features to reduce the amount of effort it takes to build the trap. Natural rock pools should be used on rock shores. Natural pools on the surface of reefs should be used on coral islands by blocking the opening as the tide recedes. Sandbars, and the ditches they enclose, can be used on sandy shores. The best fishing off sandy beaches is the lee side of offshore sandbars. By watching the swimming habits of fish, a simple dam can be built which extends out into the water forming an angle with the shore. This will trap fish as they swim in their natural path. When planning a more complex brush dam, select protected bays or inlets using the narrowest area and extending one arm almost to the shore. In small, shallow streams, the fish traps can be made with stakes or brush set into the stream bottom or weighted down with stones so that the stream is blocked except for a small narrow opening into a stone or brush pen or shallow water. Wade into the stream, herding the fish into the trap, and catch or club them when they get in shallow water. Mud-bottom streams can be trampled until cloudy and then netted. The fish are blinded and cannot avoid the nets. Freshwater crawfish and snails can be found under rocks, logs, overhanging bushes, or in mud bottoms. 1. Fish may be confined in properly built enclosures and kept for days. In many cases, it may be advantageous to keep them alive until needed and thus ensure there is a fresh supply without danger of spoilage. Mangrove swamps are often good fishing grounds. 2. At low tide, clusters of oysters and mussels are exposed on the mangrove knees or lower branches. Clams can be found in the mud at the base of trees. Crabs are very active among branches or roots and in the mud. Fish can be caught at high tide. Snails are found on mud and clinging to roots. Shellfish which are not covered at high tide or those from a colony containing diseased members should not be eaten. Some indications of diseased shellfish are shells gaping open at low tide, foul odor, and/or milky juice. Throughout the warm regions of the world, there are various plants which the natives use for poisoning fish. The active poison in these plants is harmful only to cold-blooded animals. IP can eat fish killed by this poison without ill effects. Lime thrown in a small pond or tidal pool will kill fish in the pool. Lime can be obtained by burning coral and seashells. The most common method of using fish poison plants, such as Duris root found in Southeast Asia, is to crush the plant parts, most often the roots, and mix them with water. Drop large quantities of the crushed plant into pools or the headwaters of small streams containing fish. Within a short time, the fish will rise in a helpless state to the surface. After putting in the poison, follow slowly downstream and pick up the fish as they come to the surface, sink to the bottom, or swim erratically to the bank. A stick dam or obstruction will aid in collecting fish as they float downstream. The husk of green-black walnuts can be crushed and sprinkled into small sluggish streams and pools to act as a fish stupefying agent. In the Southwest Pacific, the seeds and bark from the Barringtonia tree are commonly used as a source of fish poison. The Barringtonia tree usually grows along the seashore. Duris is a climbing leguminous plant of Southeast Asia and the Southwest Pacific Islands, including New Guinea. Its roots contain rotenone, a strong insecticide and fish poison. Also known as Jerris powder, it was formerly used as an organic insecticide used to control pests on crops such as peas. However, due to studies revealing its extreme toxicity, as well as the concentration level of rotenone to which the powder is often refined, experts in ecological and organic growing no longer consider it ecologically sound. Rotenone is still sold in the U.S. Barringtonia. Tickling can be effective in small streams with undercut banks or in shallow ponds left by receding floodwaters. Place hands in the water and reach under the bank slowly, keeping the hands close to the bottom if possible. Move the fingers slightly until they make contact with the fish. Then work the hands gently along the fish's belly until reaching its gills. Grasp the fish firmly just behind the gills and scoop it onto land. In the tropics, this type of fishing can be dangerous due to hazardous marine life in the water such as piranhas, eels, and snakes. There is no known way to detect a poisonous fish merely by its appearance. Fish that are poisonous in one area may be safe to eat in another. In general, bottom dwellers and feeders, especially those associated with coral reefs, should be suspect. Also, unusually large predator-type fish should be eaten with caution. The internal organs and roe of all tropical marine fish should never be eaten, as those parts contain a higher concentration of poison. Under certain conditions, where IP may be required to eat questionable fish, rules should be followed. A fish will be safer if it can be caught away from reefs or entrances to lagoons. Once the fish has been secured, the marine animal edibility test should be used. The fish should be cut into thin strips and boiled in successive changes of water for an hour or more. This may help since some, but not all, of the toxins are water-soluble. Further, it should be noted that normal cooking techniques and temperatures will not weaken or destroy poisons. If boiling is not possible, cut the meat into thin strips and soak in changes of seawater for an hour or so, squeezing the meat juices out as thoroughly as possible. IP should eat only a small portion of the flesh and wait 12 hours to see if any symptoms arise, if the fish will not spoil. Remember that the degree of poisoning is directly related to how much fish is eaten. If in doubt, do not eat it. The advice of native people on eating tropical marine fish may not be valid. In many instances they check edibility by first feeding fish portions to their dogs and cats. As soon as any symptoms arise, vomiting should be induced by administering warm salt water or egg whites. If these procedures do not work, try sticking a finger down the person's throat. A laxative should also be given to the victim if one is available. The victim may have to be protected from injury during convulsions. If the victim starts to foam at the mouth and exhibits signs of respiratory distress, a cricothyroidotomy may have to be performed. See Chapter 5 for more information. Morphine may help relieve pain in some cases. If the victim complains of severe itching, cool showers may give some relief. Treat any other symptoms as they arise. The thought of having a diet consisting only of plant food may be distressing to IP. This is not the case if the isolating event is entered into with a confidence and intelligence based on knowledge or experience. If IP know what to look for, can identify it, and know how to prepare it properly for eating, there is no reason why they can't find sustenance. Plants provide carbohydrates, which provide the body energy and calories. Carbohydrates keep weight and energy up, and include important starches and sugars. Another advantage of a plant diet is availability. In many instances, a situation may present itself in which procuring animal food is difficult because of injury, being unarmed, being in enemy territory, exhaustion, or being in an area which lacks wildlife. If convinced that vegetation can be depended upon for daily food needs, the next question is where to get what and how. Experts estimate there are about 300,000 classified plants growing on the surface of the earth, including many which thrive on mountain tops and on the floors of the oceans. There are two considerations that IP must keep in mind when procuring plant foods. The first consideration is determining if the plant is edible, and preferably, palatable. The next consideration is that plant food must be fairly abundant in the areas in which it is found. If it includes an inedible or poisonous variety in its family, the edible plant must be distinguishable to the average eye from the poisonous one. Usually a plant is selected because one special part is edible, such as the stalk, the fruit, or the nut. To aid in determining plant edibility, there are general rules which should be observed and an edibility test that should be performed. In selecting plant foods, the following should be considered. First, look for plant parts that contain high energy such as fruit, seeds, grains, nuts, roots, bulbs and tubers. Also, select plants resembling those cultivated by people. It is risky to rely upon a plant, or parts thereof, being edible for human consumption simply because animals have been seen eating it. When selecting an unknown plant as a possible food source, apply the following general rules. Mushrooms and fungi should not be selected. Fungi have toxic peptides, a protein-based poison which has no taste. There is no field test other than eating to determine whether an unknown mushroom is edible. Anyone gathering wild mushrooms for eating must be absolutely certain of the identity of every specimen picked. Some species of wild mushrooms are difficult for an expert to identify. Because of the potential for poisoning, relying on mushrooms as a viable food source is not worth the risk. Plants with umbrella-shaped flowers are to be completely avoided, although carrots, celery, dill, and parsley are members of this family. One of the most poisonous plants, poison water hemlock, is also a member of this family. All of the legume family should be avoided, beans and peas. They absorb minerals from the soil and cause problems. The most common mineral absorbed is selenium. Selenium is what has given loco wheat its fame. Loco wheat is a milky sap indicates a poisonous plant. Plants that are irritants to the skin should not be eaten, such as poison ivy. As a general rule, all bulbs should be avoided. Examples of poisonous bulbs are tulips and deathcomas. White and yellow berries are to be avoided as they are almost always poisonous. Approximately 1/2 of all red berries are poisonous. Blue or black berries are generally safe for consumption. Aggregated fruits and berries are always edible, for example, thimbleberry, raspberry, salmonberry, and blackberry. Single fruits on the stem are generally considered safe to eat. Plants with shiny leaves are considered to be poisonous and caution should be used. A plant that grows in sufficient quantity within the local area should be selected to justify the edibility test and provide a lasting source of food if the plant proves edible. Plants growing in the water or moist soil are often the most palatable. Plants are less bitter when growing in shaded areas. The previously mentioned information concerning plants is general. There are exceptions to every rule, but IP should only select unknown plants as a last resort. When selecting unknown plants for possible consumption, poisonous characteristics should be avoided. Apply the edibility test to only one plant at a time so if some abnormality does occur, it will be obvious which plant caused the problem. Once a plant had been selected for the edibility test, proceed as follows. 1. First, if there are any unpleasant odors such as a moldy or musty smell coming from the plant, stop testing and disregard as a possible edible plant option. Also, if the plant gives off an almond scent, it should be disregarded as a possible edible plant option. 2. Crush or break part of the plant to determine the color of its sap. If the sap is clear, proceed to the next step. 3. Touch the plant's sap or juice to the inner forearm. If there are no ill effects, such as a rash or burning sensation to the skin, then proceed with the rest of the steps. Note, sometimes heavy smokers are unable to taste various poisons, such as alkaloids. 4. If a reaction was not noted when touching the inner forearm, place some of the plant juice on the outer lip for 8 minutes. If a reaction occurs, stop the test. 5. If still no reaction, taste a small pinch of the plant and leave in the mouth for 8 minutes. If there is an unpleasant taste, such as bitterness or a numbing sensation of the tongue or lips, stop the test. If a reaction does not occur, swallow the pinch of plant. 6. After swallowing, wait 8 hours. If there is no reaction after 8 hours, chew a handful of the plant, swallow, and wait an additional 8 hours. If no reaction occurs after 8 hours, consider the tested plant part edible. 7. Keep in mind that any new or strange food should be eaten with restraint until the body has become accustomed to it. The plant may be slightly toxic and harmful when large quantities are eaten. If IP are not able to boil the plant before consumption, plant food may be prepared as follows. Leach the plant by crushing the plant material and placing it in a container. Pour large quantities of cold water over it, rinse the plant parts. Leaching removes some of the bitter elements of non-toxic plants. If leaching is not possible, IP should follow the steps taken in the edibility test. In the temperate environment, edible plants are widely varied with seeds, resins, cattail, chicory, fiddlehead fern, sorrel and others are available. In many places, the ground is thickly covered with mosses and there may be a few varieties of early flowering plants and many berry-bearing shrubs which invite birds and mammals into the open areas. Some of the largest herbivores, plant eaters, live in these evergreen forests: caribou, reindeer, moose, and deer. The small herbivores may include porcupines, several species of squirrels, mice, and rabbits. The carnivores, flesh eaters, which feed upon the smaller animals include black bear, gray wolf, lynx, wolverine, red fox, and weasel. Multitudes of insects provide food for the birds. These insects may also present a menace to IP. A large variety of birds feed not only on insects but also on plants. More information is available in the sustenance chapter and through self-study. In winter, the primary edible food plants available include rootstocks, roots, seeds, resins, from pines, infusion, teas, from evergreen needles, bark, inner part. During summer months, many more plants are available for food, including tree nuts such as almonds, walnuts, pine nuts, chestnuts, hazelnuts, and acorns, agave, sweet acacia, water plantain, baobab, wild rhubarb, wild sorrel, cattail, tree ferns, spreading wood ferns, bracken fern, and fiddlehead ferns, wild dock, chicory, juniper, common jujube, wild lily and water lily, water arum. IP will find some plants which are completely edible, but many plants which they may find will have only one or more identifiable parts having food and thirst quenching value. The variety of plant component parts which might contain substance of food value. The potato is an example of an edible tuber. Many other kinds of plants produce tubers such as the tropical yam, the Eskimo potato, and tropical water lilies. Tubers are usually found below the ground. Tubers are rich in starch and should be cooked by roasting in an earth oven or by boiling to break down the starch for ease of digestion. The following are some plants with edible tubers: arrowroot, East Indian; taro, cassava, tapioca. Many plants produce roots which may be eaten. Edible roots are often several feet in length. In comparison, edible rootstocks are underground portions of the plant which have become thickened and are relatively short and jointed. Both true roots and rootstocks are storage organs rich in stored starch. The following are some plants with edible roots or rootstocks: rhizomes, baobab, pine, screw, bean, goa. All edible shoots grow in much the same fashion as asparagus. The young shoots of ferns, fiddleheads, and especially those of bamboo and numerous kinds of palms are desirable for food. Some kinds of shoots may be eaten raw, but most are better if first boiled for 5 to 10 minutes, the water drained off, and the shoots re-boiled until they are sufficiently cooked for eating, parboiled. The following are some plants with edible shoots: palm, coconut, bamboo, cattail, rock tribe. The leaves of spinach-type plants, pollards, such as wild mustard, wild lettuce, and lamb quarters, may be eaten either raw or cooked. Prolonged cooking, however, destroys most of the vitamins. Plants which produce edible leaves are perhaps the most numerous of all edible plants. The young tender leaves of nearly all non-poisonous plants are edible. The following are only some plants with edible leaves. Sorrel, wild. Dock. Plantain. Some plants have edible pith in the center of the stem. The pith of some kinds of tropical plants is quite large. Pith of the sago palm is particularly valuable because of its high food value. The following are some palms with edible pith, starch. Coconut. Rattan. Sugar. The inner bark of a tree, the layer next to the wood, may be eaten raw or cooked. It is possible in northern areas to make flour from the inner bark of such trees as the cottonwood, aspen, birch, willow, and pine. The outer bark should be avoided in all cases because this part contains large amounts of bitter tannin. Pine bark is high in vitamin C. The outer bark of pines can be cut away and the inner bark stripped from the trunk and eaten fresh, dried, cooked, or pulverized into flour. Bark is most palatable when newly formed in spring. As food, bark is most useful in the Arctic regions, where plant food is often scarce. Fresh flowers may be eaten as part of a salad or to supplement a stew. The hibiscus flower is commonly eaten throughout the Southwest Pacific area. In South America, the people of the Andes eat nasturtium flowers. In India, it is common to eat the flowers of many kinds of plants as part of a vegetable curry. Flowers of desert plants may also be eaten. The following are some plants with edible flowers. Apple. Papaya. Banana. Pollen looks like yellow dust. All pollen is high in food value and is found in some plants, especially the cattail. Quantities of pollen may easily be collected and eaten as a kind of gruel. Edible fruits can be divided into sweet and non-sweet, vegetable, types. Both are the seed-bearing parts of the plant. Sweet fruits are often plentiful in all areas of the world where plants grow. For instance, in the far north, there are blueberries and crowberries, in the temperate zones, cherries, plums, and apples, and in the American deserts, fleshy cactus fruits. Tropical areas have more kinds of edible fruit than other areas, and the list would be endless. Sweet fruits may be cooked, or for maximum vitamin content, left uncooked. Common vegetable fruits include the tomato, cucumber, and pepper. The following are some plants with edible fruits. Apple, wild. Huckleberry. Prickly pear. Seeds of many plants, such as buckwheat, ragweed, amaranth, and goosefoot, contain oils and are rich in protein. The grains of all cereals and many other grasses, including millet, are also extremely valuable sources of plant protein. They may either be ground between stones, mixed with water and cooked to make porridge, parched or roasted over hot stones. In this state, they are still wholesome and may be kept for long periods without further preparation. Figure 1730. The following are some plants with edible seeds and grains. Rice. Screw pine. Water lily, temperate. Nuts are among the most nutritious of all raw plant foods and contain an abundance of valuable protein. Plants bearing edible nuts occur in all the climatic zones of the world and in all continents except in the Arctic regions. Most nuts can be eaten raw, but some, such as acorns, are better when cooked. The following are some plants with edible nuts. Almond. Beech nut. Pine. The pulp around the seeds of many fruits is the only part that can be eaten. Some fruits produce sweet pulp, others have a tasteless or even bitter pulp. Plants that produce edible pulp include the custard apple, ingopod, breadfruit, and tamarind. The pulp of breadfruit must be cooked, whereas in other plants, the pulp may be eaten uncooked. Use the edibility rules in all cases of doubt. Gum and resin are sap that collects and hardens on the outside surface of the plant. It is called gum if it is soft and soluble, and resin if it is hard and not soluble. Most people are familiar with the gum which exudes from cherry trees and the resin which seeps from the pine trees. These plant byproducts are edible and are a good source of nutritious food which should not be overlooked. Vines or other plant parts may be tapped as potential sources of usable liquid. The liquid is obtained by cutting the flower stalk and letting the fluid drain into some sort of container such as a bamboo section. Palm sap with its high sugar content is highly nutritious. The following are some plants with edible sap and drinking water. Sweet acacia, water. Saxaul, water. Nipa palm, sap. There are more types of animals in the jungles of the world than in any other region. A jungle visitor who is unaware of the lifestyle and eating habits of these animals would not observe the presence of a large number of the animals. Game trails are the normal routes along which animals travel through a jungle. Some of the animals used as food are hedgehogs, porcupines, anteaters, mice, wild pigs, deer, wild cattle, bats, squirrels, rats, monkeys, snakes, and lizards. Reptiles are located in all jungles and should not be overlooked as a food source. All snakes should be considered poisonous and extreme caution used when killing the animal for a food source. All cobras should be avoided since the spitting cobra aims for the eyes. The venom can blind if not washed out immediately. Lizards are good food, but may be difficult to capture since they can be extremely fast. A blow to the head of a reptile will usually kill it. Crocodiles and caimans are extremely dangerous on land as well as in the water. Frogs can be poisonous. All brilliantly colored frogs should be totally avoided. Some frogs and toads in the tropics secrete substances through the skin which has a pungent odor. These frogs are often poisonous. The larger, more dangerous animals should be left alone. Seafood such as fish, crabs, lobster, crayfish, and small octopi can be poked out of holes, crevices, or rock pools. IP should be ready to spear them before they move off into deep water. If they are in deeper water, they can be teased shoreward with a baited hook or stick. A number of methods can be used for procuring fish. Some are listed below. Hook and line fishing on a rocky coast requires a lot of care to keep the line from becoming entangled or cut on sharp edges. Most shallow water fish are nibblers. Unless the bait is well placed and hooked and the barb of the hook offset by bending, the bait may be lost without catching a fish. Use hermit crabs, snails, or the tough musclefish shellfish as bait. Take the cracked shells and any other animal remains and drop them into the area to be fished. This brings the fish to the area and provides a better opportunity to catch the fish. Examine stomach contents of the first fish caught to determine what the fish are feeding on. Jigging is taking a baited or spoon hooked it repeatedly beneath the surface of the water is sometimes effective. This method may be used at night. Spearing is difficult except when the stream is small and the fish are large and numerous during the spawning season, or when the fish congregate in pools. Make a spear by sharpening a long piece of wood, lashing two long thorns on a stick, or fashioning a bone spear point, and take a position on a rock over a fish run. Wait patiently and quietly for a fish to swim by. Examples of tropical seafood include: a small heap of empty oyster shells near a hole may indicate the presence of an octopus. To catch an octopus located in a hole, push a long stick into the hole where the octopus is located. When tentacle comes out of the hole, grab the tentacles and pull out the octopus and stick. Also, a baited hook placed in the hole will sometimes catch the octopus. IP should allow the octopus to surround the hook and line before lifting. Octopi are not scavengers like sharks, but they are hunters, fond of spiny lobster and other crab-like fish. At night, octopus come into shallow water and can be easily seen and speared. Snails and limpets cling to rocks and seaweed from the low water mark up. Large snails called chitons adhere tightly to rocks just above the surf line. Mussels usually form dense colonies in rock pools, on logs, or at the bases of boulders. Mussels are poisonous in tropical zones during the summer, especially when seas are highly phosphorescent or reddish. Sea cucumbers and conchs, large snails, live in deep water. The sea cucumber will shoot out its stomach when excited. The stomach is not edible. The skin and the 5 strips of mussel can be eaten after boiling. Conches can be boiled out of their shells and have very firm flesh. Use care when picking conches up. The bottom of their foot has a bony covering which can severely cut IP who picks them up. The safest fish to eat are those from the open sea or deep water beyond the reef. Silvery fishes, river eels, butterfly fishes, and flounders from bays and rivers are good to eat. Land crabs are common on tropical islands and are often found in coconut groves. An open coconut can be used for bait. There are over 265 species of marine turtles. Of these, only 5 have been reported as poisonous and dangerous to IP. Many of these species are commonly eaten, but for some unknown reason, these same turtles become extremely toxic under certain conditions. Basically, the main species to be concerned with are the green, the hawksbill, and the leatherback turtles. These turtles are found mainly in tropical and subtropical seas but can also be found in temperate waters. The origin of turtle poison is unknown, but some investigators suggest it comes from the poisonous marine algae eaten by the turtles. It should be noted that a species of turtle may be safe to eat in one area but deadly in another. There is absolutely no way IP can distinguish between a poisonous and non-poisonous sea turtle just by looking at it or by examining any part of it. Toxicity may occur at any time of the year. However, the most dangerous months appear to be the warmer months. The degree of freshness also has nothing to do with how poisonous the turtle is. The symptoms will vary with the amount of turtle ingested. Symptoms will develop within a few hours to a few days after eating the food. These symptoms include nausea, vomiting, diarrhea, pain, sweating, coldness in the extremities, vertigo, dry and burning lips and tongue, tightness of the chest, drooling, and difficulty in swallowing. Other victims reported a heavy feeling of the head, a white coating on the tongue, diminished reflexes, coma, and sleepiness. About 44% of the victims poisoned by marine turtles die. There is no known antidote for this kind of poisoning. There is no specific treatment symptomatically. If there is the slightest suspicion about the edibility of a marine turtle, it should not be eaten, or at least the marine animal edibility test should be used. Turtle liver is especially dangerous to eat because of its high vitamin A content. Red tide is a name used to describe the reddish or brownish coloration in salt water, resulting from tiny plants and organisms called plankton, which suddenly increase tremendously in numbers. Red tides appear in waters worldwide. In the United States, they are most common off the coasts of Florida, Texas, and Southern California. Although most red tides are harmless, some may kill fish and other water creatures. Still, other types of red tides do not kill sea life, but cause the shellfish feeding on them to be poisonous. Some of these creatures secrete poisons which can paralyze and kill fish, or can kill fish by using nearly all of the oxygen in the water. Although the exact reason for the sudden increase of the plankton is unknown, there is evidence that shows favorable food, temperature, sunlight, water currents, and salt in the water will increase the population. It is not unusual for it to remain from a few hours to several months. IP should not eat any fish that are found dead. In jungle environments, rainfall is distributed throughout the year and there is a lack of cold season. This allows plants in the humid regions to grow, produce leaves and flower year-round. Some plants grow very rapidly. For example, the stem of the giant bamboo may grow more than 22 inches in a single day. IP in search of plant food should apply some basic principles to the search. IP are lucky to find a plant that can readily be identified as edible. If a plant resembles a known plant, it is very likely to be of the same family and can be used. If a plant cannot be identified, the edibility test should be applied. IP will find many edible plants in the tropical forest, but chances of finding them in abundance are better in an area that has been cultivated in the past. Secondary growth. Citrus fruit trees may be found in uncultivated areas, but are primarily limited to areas of secondary growth. The many varieties of citrus fruit trees and shrubs have leaves 2 to 4 inches long alternately arranged. The leaves are leathery, shiny, and evergreen. The leaf stem is often winged. Small, usually green, spines are often present by the side of the bud. The flowers are small and white to purple in color. The fruit has a leathery rind with numerous glands and is round and fleshy with several cells, fruit sections or slices, and many seeds. A great number of wild and cultivated fruits, oranges, limes, lemons, etc., native to the tropics are eaten raw or used in beverages. Taro can be found in both secondary growth and in virgin areas. It is usually found in the damp, swampy areas in the wild, but certain varieties can be found in the forest. It can be identified by its large heart-shaped or arrowhead-shaped leaves growing at the top of a vertical stem. The stem and leaves are usually green and rise a foot or more from a tuber at the base of the stem. Taro leaf tips point down, poisonous elephantier points up. All varieties of taro must be cooked to break down the irritating crystals in the plant. Wild pineapple can be found in the wild, and common pineapples may be found in secondary growth areas. The wild pineapple is a coarse plant with long clustered, sword-shaped leaves with sawtoothed edges. The leaves are spirally arranged in a rosette. Flowers are violet or reddish. The wild pineapple fruit will not be as fully developed in its wild state as when cultivated. The seeds from the flower of the plant are edible as well as the fruit. The ripe fruit may be eaten raw, but the green fruit must be cooked to avoid irritation. The leaf fibers make excellent lashing material and ropes can be manufactured from it. Yams may be found cultivated or wild. There are many varieties of yam, but the most common has a vine with square-shaped cross-section and 2 rows of heart-shaped leaves growing on opposite sides of the vine. The vine can be followed to the ground to locate the tuber. The tubers should be cooked to destroy the poisonous properties of the plant. Ginger grows in the tropical forest and is a good source of flavoring for food. It is found in shaded areas of the primary forest. The ginger plant grows 5 to 6 feet high. It has seasonal white snapdragon-type flowers, while some variations have red flowers. The leaves when crushed produce a very sweet odor and are used for seasoning or tea. The tea can be used to treat colds and fever. The coconut palm is found wild on the seacoast and cultivated in areas inland. The coconut palm is a tree 50 to 100 feet high, either straight or curved, marked with ring-like leaf scars. The base of the tree is swollen and surrounded by a mass of rootlets. The leaves are leathery and reach a length of 15 to 20 feet. The leaves make excellent sheathing for shelter. The fruit grows in clusters at the top of the tree. Each nut is covered with a fibered hard shell. The heart of the coconut palm is edible and is found at the top. The new leaves grow out of the heart. Cutting the tree down and removing the leaves allow an IP to gain access to the heart. The flower of the coconut tree is also edible and is best used as a cooked vegetable. The germinating nut is filled with a meat that can be eaten raw or cooked. There are many other varieties of palm found in the tropics which have edible hearts and fruits. The papaya is an excellent source of food and can be found in secondary growth areas. The tree grows to a height of 6 to 20 feet. The large, dark green, many-fingered, rough-edged leaves are clustered at the top of the plant. The fruit grows on the stem clustered under the leaves. The fruit is small in the wild state, but cultivated varieties may grow to 15 pounds. The peeled fruit can be eaten raw or cooked. The peeling should never be eaten. The green fruit is usually cooked. The milky sap of the green fruit is used as a meat tenderizer. Care should be taken not to get it in the eyes. Always wash the hands after handling fresh green papayas. If some of the sap does get in the eyes, they should be washed immediately. Cassava, tapioca, can be found in secondary growth areas. It can be identified by its stalk-like leaves which are deeply divided into numerous pointed sections or fingers. The woody, red, stem of the plant is slender and at points appears to be sectioned. When found growing wild in secondary growth areas, pull the trunks to find where a root grows. When one is found, a tuber can be dug. Tubers have been found growing around a portion of the stem that was covered with vegetation. The brown tuber of the plant is white inside and must be boiled or roasted. The tuber must also be peeled before boiling. The green-stemmed species of cassava is poisonous and must be cooked in several changes of water before eating it. Ferns can be found in the virgin tropical forest or in secondary growth areas. The new leaves, fiddleheads, at the top are the edible parts. They are covered with fuzzy hair which is easily removed by rubbing or washing. Some can be eaten raw, but as a rule, should be cooked as a vegetable. Sweet sops can be found in the tropical forest. It is a small tree with simple, oblong leaves. The fruit is shaped like a blunt pine cone with thick gray-green or yellow, brittle spines. The fruit is easily split or broken when ripe, exposing numerous dark brown seeds embedded in the cream-colored, very sweet pulp. The star apple is common in the tropical forests. Figure 1743. The tree grows up to a height of 60 feet and can be identified by the leaves which have shiny, silky, brown hairs on the bottom. The fruit looks like a small apple or plum with a smooth greenish or purple skin. The meat is greenish in color and milky in texture. When cut through the center, the brown, elongated seeds make a figure like a 6 or 10 pointed stars. The fruit is sweet and eaten only when fresh. When cut, the rind, like other parts of the tree, will emit a white sticky juice or latex. It is not poisonous, which is an exception to the milky sap rule. Of the 300,000 different kinds of wild plants in the world, a large number of them are found in the tropics and many of them are potentially edible. Only a small number of jungle plants have been discussed. It would be of great benefit to anyone flying over or passing through a tropical environment to study the plant foods available in this type of environment. Although not as readily available as in the tropical climate, food is available and obtainable in dry climates. Plant life in the desert is varied due to the different geographical areas. It must be remembered, therefore, that available plants will depend on the actual desert, the time of year, and if there has been any recent rainfall. Potential IP should be familiar with plants in the area they will be operating in or flying over. Date palms are located in most deserts and are cultivated by the native people around oases and irrigation ditches. They bear a nutritious, oblong, black fruit, when ripe. Fig trees are normally located in tropical and subtropical zones. However, a few species can be found in the deserts of Syria and Europe. Many kinds of figs are cultivated and the fruit can be eaten when ripe. Most figs resemble a top or a small pear somewhat squashed in shape. Ripe figs vary greatly as to palatability. Many are hard, woody, covered with irritating hairs, and worthless as survival food. The edible varieties are soft, delectable, and almost hairless. They are green, red, or black when ripe. Millet, a grain-bearing plant, is grown by natives around oases and other water sources in the Middle East deserts. Most cacti fruits and leaves have spines to protect them from birds and animals seeking water stored in the stems or leaves. The fruit and flower of all cacti are edible. Some fruits are red, some yellow, but all are soft when ripe. Any of the flat-leaf variety, such as the prickly pear, can be boiled and eaten as greens, like spinach, if the spines are first removed. Although the cactus originates in the American deserts, the prickly pear has been introduced to the desert hedges in Asia, Africa, the Near East, and Australia, where it grows profusely. Prickly pear is native and most abundant in the American deserts, but has been introduced into the Gobi, Sahara, and Australian deserts, and other parts of the world. Barrel cactus is found in many places, but is only native to the North American deserts. It grows up to 5 to 6 feet high. Saguaro, giant, cactus is abundant in southern Arizona and in Sonora, Mexico and can grow up to 50 feet tall. There are 2 types of onions in the Gobi Desert. A hot, strong, scallion type grows in the late summer. It will improve the taste of food, but should not be used as a primary food. The highland onions grow 2 to 2.5 inches in diameter. These can be eaten like apples and the greens can also be eaten raw or cooked. Apple grows to about 4 feet tall in sandy deserts. The fresh flowers can be eaten. The dry twigs can be crushed and used as a tea substitute. It is found in the Sahara and Arabian deserts. Acacia is most common in the Sahara, Gobi, and Australian desert regions, and in the warmer and drier parts of America. The beans can be crushed and cooked as porridge. It is spiny with many branches and grows to 10 feet tall. Roots yield water 4 to 5 feet from the tree trunk. 6L can be found on the salt deserts of the Gobi Desert. The bark acts as water storage and is a good water source. St. John's bread can be found along the border of the Mediterranean coast of the Sahara and across the Arabian desert. It grows 40 to 50 feet tall and seeds can be pulverized and cooked as porridge, the most nutritious plant food in the Middle East. Wild desert gourds are found in the Sahara and Arabian deserts. They have a vine which grows from 8 to 30 feet long, and produce a melon-like poisonous fruit. The seed can be eaten when roasted or boiled. The flowers are also edible. Succulent plants are filled with juices and store moisture to survive. The surface is covered with a layer of wax or a blanket of fine hairs for protection against the heat. The moisture is contained in tough cellulose that is not digestible and must be manually broken down to release the water. All desert flowers can be eaten except those with milky or colored sap. All grasses are edible. Usually the best part is the whitish tender end that shows when the grass stalk is pulled from the ground. All grass seeds are edible. Animal food sources may be used to supplement diets and provide needed protein and fats. When looking at a desert area, it is sometimes difficult to visualize an abundance of animal life existing in it. There is, however, a great quantity of animal life present. Most are edible, but some may be hazardous to IP during the procurement stage. Some of the abundant animal life includes: at the peak of seasonal plant growth, the desert crawls and buzzes with an enormous number and variety of beetles, ants, wasps, moths, and bugs. They appear with the first good rains and generally feed during nighttime. IP can harvest crickets, locusts, grasshoppers, and caterpillars in the desert. On the plains of the Sonora and Chihuahua deserts, several species of freshwater shrimp appear every summer in warm temporary ponds. In the Mojave Desert, where summer rains are rare, they may appear only a few times in a century. Snakes, lizards, etc., have adapted well to the desert environment. Care must be observed when procuring them as some are hazardous, such as the Gila monster and rattlesnake. In general, desert birds stay in areas of heavier vegetation and many need water daily. Therefore, most desert birds will be found within short flights of some type of water source. Many birds will migrate during the drought season. If an abundance of birds is seen, insects, vegetation, and a water source will normally be nearby. Rabbits, prairie dogs, and rats remain in the shade or burrow into the ground, protecting themselves from the direct sun and heated air as well as from the hot desert surface. Larger mammals are also found in the desert. This group consists of but is not limited to gazelles, antelope, deer, foxes, small cats, badgers, dingoes and hyenas. Most are nocturnal and generally avoid humans. Many roam at night eating smaller game and insects, and a few eat plants. Only few of these mammals can be hazardous to IP, although all of them should be approached with caution. Only a few of the available animals and plants have been discussed. If the possibility of having to survive in a desert area exists, IP should try to become familiar with the food source available in that area. In the snow and ice climates, food is more difficult to find than water. Animal life is normally more abundant during the warm months, but it can still be found in the cold months. Fish are available in most waters during the warmer months, but they congregate in deep waters, large rivers, and lakes during the cold months. Also, some edible plant life can be found throughout the year in most areas of the Arctic. All animals in the Arctic regions are edible, but the livers of seals and polar bears must not be eaten because of the high concentration of vitamin A. Death can result from ingesting large quantities of the liver. On the open sea ice, game animals such as seal, walrus, polar bear, and fox are available. Also, many types of birds can be found during the warmer months and fish can be caught throughout the year. Seals will probably be the main source of food when stranded on the open sea ice. They can be found in open leads, areas of thin ice, or where snow has drifted over a pressure ridge forming a cave which could have open water or very thin ice. Caution must be taken in these areas. They may also house polar bears which feed primarily on seals. Newborn seals have trouble staying afloat or swimming and will be found on the ice in the early summer. The seal cubs can be easily killed with a club, spear, knife, or firearm and make an excellent source of food. The meat, blubber, fat, and coagulated milk in their stomachs are edible. When killing a cub, it is best to keep a lookout for the mother as she tends to protect her offspring in any way possible. Seals must surface periodically to breathe. When the ice pack is thin, the seals poke their noses through the ice and take a breath of air in the lead or in open water. In thick ice, the seal will chew or claw a breathing hole through the ice. Normally most seals will have more than one breathing hole. In hunting seals, it is best to take a position beside a breathing hole and wait until a seal comes up to breathe, then spear or strike it on the head with a club. Seals are very sensitive to blows on or around the nose. They will often lose consciousness but not die. Also, a hook can be suspended in a breathing hole so it hangs down at least 6 inches below the ice. When a seal comes to breathe, it can become hooked when it tries to depart the breathing hole. Seals can be recovered by gaffing or grabbing by hand, but in some cases, the breathing hole might have to be enlarged to pull the body through. If the seal is killed in open water, a mannock or grapple hook can be used to retrieve it. All seals killed in open water or those that fall into open water should be recovered immediately. During the cold months, they will float for quite a while, but during the warm months or when a female is nursing young, they sink rapidly. This is due to the loss of body fat. Birds are plentiful during the summer months and can be procured by spearing, clubbing, catching with a baited fish hook, or use of a weapon. On tundra areas, there are a large variety of animals available as a food source. The large game consists of caribou, muskoxswain, sheep, wolf, and bears. Even though the large game animals can be a food source, they will be difficult to procure if a firearm is not available. Therefore, they should be considered a hazard to IP without a firearm. In the spring, bears tend to congregate along rivers and streams due to the amount of food available, normally salmon. During certain seasons of the year, bears will be found feeding at berry patches in which these areas should be avoided. Small game animals of the tundra include hares, lemmings, mice, ground squirrels, marmots, and foxes. They may be trapped or killed the entire year. Most prefer some cover and can be found in shallow ravines or in groves of short willows. Both ground squirrels and marmots hibernate in the winter. In summer, ground squirrels are abundant along sandy banks of large streams. Marmots typically live among the rocks in the mountains, usually near the edge of a meadow or in deep soil. The marmot always seeks relief in the same spot not far from a hidden entrance. To find the burrow in rocky areas, look for a large patch of orange-colored lichen on rocks. It grows best on animal and bird dung. When snaring, it is best to use a simple loop made of strong line or wire. The wire must be a 2-strand twisted wire since metal becomes brittle in the cold and breaks very easily. Other snares and triggers will be less effective in the cold climate. A gill net can be used as a snare by spreading it across a trail so that the animal will entangle itself. The Arctic is the breeding ground for many birds. In summer, ducks, geese, loons, and swans build their nests near ponds on the coastal plains or bordering lakes or rivers of the low tundra. A few ducks on a small pond usually indicates that setting birds may be found and flushed from the surrounding shores. Swans and loons normally nest on small, grassy islands in the lakes. Geese crowd together near large rivers or lakes. Smaller wading birds customarily fly from pond to pond. Grouse and ptarmigan are common in the swampy forest regions of Siberia. Seabirds may be found on cliffs or small islands off the coast. Their nesting areas can often be located by their flights to and from their feeding grounds. Jaeger gulls are common over the tundra, and frequently rest on higher hillocks. In the winter, fewer birds are available because of migratory patterns. Ravens, grouse, ptarmigan, and owls are the primary birds available. Ptarmigan are seen in pairs or flocks, feeding along grassy or willow-covered slopes. The eggs and young birds are an excellent food source and can be easily procured. As in the tundra areas, the forested areas in the Arctic and Arctic-like areas abound in wildlife. The large game species include moose, deer, caribou, and bear. Small game of the forests includes hares, squirrels, porcupine, muskrat, and beaver. They can be snared or trapped easily in winter or summer. Small animal trails can be found in the winter with great ease. Most animals do not like to travel in deep snow and tend to travel the same trail often. This results in a trail that resembles a small superhighway where the snow is packed down well below the normal snow level. Most trails will also be located in heavy cover and undergrowth or parallel to roads and open areas. The same trails will normally be used during the summer. During the summer months, the open water provides an excellent opportunity to procure all types of seafood, both freshwater and saltwater. Arctic and tomcod, sculpin, eelpout, and other fish may be caught in the ocean. The ocean shores are rich hunting grounds for edible sea life such as clams, mussels, scallops, snails, limpets, sea urchins, chitons, and sea cucumbers. The inland lakes and rivers of the surrounding coastal tundra generally have plenty of fish which are easily caught during the warmer season. In the North Pacific and in the North Atlantic extending slightly northward into the Arctic Sea, the coastal waters are rich in all seafood such as fish, crawfish, snails, clams, oysters, and the king crab. Generally clams, mussels, scallops, snails, limpets, sea urchins, chitons and sea cucumbers can be hand-picked in tide pools on ocean shores. Fish can be netted, speared, clubbed, or caught with a hook and line. In the spring, king crab come close to shore and may be caught on fish lines set in the deep water or by lowering baiting lines through holes cut in the ice. After freeze-up, fishing is still possible through the ice. Fish tend to congregate in the deepest water possible. A hole should be cut through the ice at the estimated deepest point. Other good locations are at outlets or where tributaries flow into lakes or ponds. The ice is normally thinner over rapid-moving water and at the edges of deep streams or rivers with snowdrifts extending out from the banks. Open water is often marked by a mist or fog formed over the area by vaporizing water. All methods of procuring fish in the summer will work in the winter. Shallow lakes, rivers, or ponds can freeze completely, killing off all fish life. All sea life can be eaten raw, but cooking usually makes it more palatable. Do not eat shellfish that are not covered at high tide. Never eat any type of shellfish that is dead when found, or any that do not close tightly when touched. Poisonous fish are rarer in the Arctic than in the tropics. Some fish, such as sculpins, lay poisonous eggs, but eggs of the salmon, herring, or freshwater sturgeon are safe to eat. In Arctic or subarctic areas, the black mussel may be very poisonous. If mussels are the only available food, select only those in deep inlets far from the coast. Remove the black meat, liver, and eat the white meat. Arctic shark meat is also poisonous. High concentration of vitamin A. The plant life of the Arctic regions is generally small and stunted due to the effects of permafrost, low mean temperatures, and a short growing season. On the barren tundra areas, a wide variety of small edible plants and shrubs exist. During the short summer months on the tundra, Labrador tea, fireweed, coltsfoot, dwarf Arctic birch, willow, and numerous other plants and berries can be found. During the winter, roots, rootstocks, and frozen berries can be found beneath the snow. Lichens and mosses are abundant but should be selected carefully as some species are poisonous. In bog or swamp areas, many types of water sedge, cattail, dwarf birch, and berries are available. During spring and summer, many young shoots from these plants are easily collected. The wooded areas of the Arctic contain a variety of trees, birch, spruce, poplar, aspen, and others. Berry-producing plants can also be found, such as blueberries, cranberries, raspberries, cloudberries, and crowberries. Wild rose hips, figure 1747, Labrador tea, alder, and other shrubs are very abundant. Many wild edible plants are highly nutritious. Greens are particularly rich in carotene, vitamin A. Leafy greens, many berries, and rose hips are all rich in ascorbic acid, vitamin C. Many roots and rootstocks contain starch and can be used as a potato substitute in stews and soups. Although there are several types of edible mushrooms, fungi, and puffballs in the Arctic, a person should avoid ingesting them because it is difficult to identify the poisonous and non-poisonous species. During the growing season, the physical characteristics can change considerably, making positive identification even more difficult. There are many poisonous plants and a few poisonous berries in the Arctic. Very few cause death, many will cause extreme nausea, dizziness, abdominal pain, and diarrhea. Contact poisonous plants, such as poison ivy, are not found in the Arctic. Some of the more common poisonous plants: buttercup, death commas, false hellebore, monkshood and larkspur, lupine, vetch and loca weed, poison hemlock. When selecting edible plants, choose young shoots when possible, as these will be the most tender. Plants should be eaten raw to obtain the most nutritive value. Some of the more common edible plants are: dandelions generally grow with grasses but may be scattered over rather barren areas. Both leaves and roots are edible raw or cooked. The young leaves make good greens. The roots, when roasted, are used as a substitute for coffee. Black and white spruce trees are generally the northernmost evergreens. These trees have short, stiff needles that grow singularly rather than in clusters like pine needles. The cones are small and have thin scales. Although the buds, needles, and stems have a strong resinous flavor, they provide essential vitamin C by chewing them raw. In spring and early summer, the inner bark can be used for food. The dwarf Arctic birch is a shrub with thin tooth-edged leaves and bark which peels off in sheets. The fresh green leaves and buds are rich in vitamin C. The inner bark may also be eaten. There are many different species of willow in the Arctic. Young tender shoots may be eaten as greens, and the bark of the roots is also edible. They have a decidedly sour taste but contain a large amount of vitamin C. Lichens are abundant and widespread in the far north and can be used as a source of emergency food. Many species are edible and rich in starch-like substances, including Iceland mouse, peat moss and reindeer lichen. Beard lichen growing on trees has been used as food by Indians. However, some of it contains a bitter acid which causes irritation of the digestive tract. If lichens are boiled, dried, and powdered, this acid is removed and the powder can then be used as flour or made into a thick soup. Almost all sea life is not only edible, but is also an excellent source of nutrients essential to humans. The protein is complete because it contains all the essential amino acids, and the fats are similar to those of vegetables. Seafoods are high in minerals and vitamins. The majority of life in the sea, fish, birds, plants, and aquatic animals, is edible. Most seaweed is edible and a good source of food, especially for vitamins and minerals. Some seaweed contains as much as 25% protein, while others are composed of over 50% carbohydrates. At least 75 different species are used for food by seacoast residents around the world. For many people, especially the Japanese, seaweeds are an essential part of the diet, and the most popular varieties have been successfully farmed for hundreds of years. The high cellulose content may require gradual adaptation because of their laxative quality if they comprise a large part of the diet. As with vegetables, some species are more flavorful than others. Generally, leafy green, brown, or red seaweeds can be washed and eaten raw or dried. The following list of edible seaweeds gives a description of the plant, tells where it may be found, and in many cases, suggests a method of preparation. Common green seaweeds, often called sea lettuce, are in abundance on both sides of the Pacific and North Atlantic Oceans. After washing it in clean water, it can be used as a garden lettuce. The most common edible brown seaweeds are the sugarrack, kelp, and Irish moss. The young stalks of the sugarrack are sweet to taste. This seaweed is found on both sides of the Atlantic and on the coasts of China and Japan. Edible kelp has a short cylindrical stem and thin, wavy olive green or brown fronds that grow 1 to several feet in length. It is found in the Atlantic and Pacific Oceans, usually below the high tide line on submerged ledges and rocky bottoms. Kelp should be boiled before eating. It can be mixed with vegetables or soup. Irish moss, a variety of brown seaweed, is quite edible, and is often sold in marketplaces. It is found on both sides of the Atlantic Ocean and can be identified by its tough, elastic, and leathery texture. However, when dried, it becomes crisp and shrunken. It can be found at or just below the high tide line and is sometimes found cast upon the shore. It should be boiled before eating. A great variety of red, warm water seaweed is found in the South Pacific area. This seaweed accounts for a large portion of the native diet. When found on the open sea, bits of floating seaweed may not only be edible but often contains tiny animals that can be used for food. The small fish and crabs can be dislodged by shaking the clump of seaweed over a container. A great variety of red, warm water seaweed is found in the South Pacific area. This seaweed accounts for a large portion of the native diet. When found on the open sea, bits of floating seaweed may not only be edible but often contains tiny animals that can be used for food. The small fish and crabs can be dislodged by shaking the clump of seaweed over a container. Plankton includes both minute plants and animals that drift about or swim weakly in the ocean. These basic organisms in the marine food chain are generally more common near land since their occurrence depends upon the nutrients dissolved in the water. Plankton can be caught by dragging a net or sea anchor through the water. The taste of the plankton will depend upon the types of organisms predominant in the area. If the population is mostly fish larvae, the plankton will taste like fish. If the population is mostly crab or shellfish larvae, the plankton will taste like crab or shellfish. Plankton contains valuable protein, carbohydrates and fats. Because of its high chitin and cellulose content, however, plankton cannot be immediately digested in large quantities. Therefore, anyone subsisting primarily on a plankton diet must gradually increase the quantities consumed. Most of the planktonic algae are smaller than the planktonic animals and, although edible, are less palatable. Some plankton algae, for example, those that cause red tides and paralytic shellfish poisoning, are toxic to humans. If IP are going to use plankton as a food source, there must be a sufficient supply of fresh water. For drinking, each plankton catch should be examined to remove all stinging tentacles broken from jellyfish or Portuguese men of war. The primarily gelatinous species may also be selectively discarded since their tissues are predominantly composed of salt water. When the plankton is found in subtropical waters during the summer months, and the presence of poisonous dinoflagellates is suspected, due to discoloration or high luminescence of the ocean, the edibility test should be applied before eating. The final precaution before ingesting plankton is to feel or touch the plankton to check for species that are especially spiny. The catch should be sorted, visually, or dried and crushed before eating if it contains large numbers of these spiny species. If a fishing kit is available, the task of fishing will be made much easier. Small fish will usually gather under the shadow of the raft or in clumps of floating seaweed. These fish can be eaten or used as bait for larger fish. A net can also be used to procure most sea life. Also, a light source such as a flashlight or a full moon can be used to attract certain types of fish. It is not advisable to secure fishing lines to the body or the raft. A large fish may pull a person out of the raft or damage the raft itself. Fish, bait, or bright objects dangling in the water can attract large dangerous fish. All large fish should be killed outside the raft by a blow to the head or by cutting off the head. Seabirds have proven to be a useful food source which may be more easily caught than fish. IP have reported capturing birds by using baited hooks, by grabbing, and by shooting. Freshly killed birds should be skinned, rather than plucked, to remove the oil glands. They can be eaten raw, sun-dried, or cooked. The gullet contents can be a good food source. The flesh should be eaten or preserved immediately after cleaning. The viscera, along with any other unused parts, Make good fish bait. Marine mammals are rarely encountered by a person in the water, although they may be seen from a distance. Any large mammal is capable of inflicting injuries, but they will generally avoid people. The killer whale, orca, is rarely seen and, although large enough to feed on humans, has never been known to do so. Almost all sea mammals are a good source of food but difficult to obtain. The liver, especially of any Arctic or cold water mammal, should not be eaten because of toxic concentrations of vitamin A. All sea life must be cleaned, cut up, and eaten as soon as possible to avoid spoilage. Any meat left over can be preserved by sun-drying or smoking. The internal parts can be used as bait. General rules should be followed to identify any features that would indicate that sea life is inedible prior to preparation. IP must know how to use the meat of game and fish to their advantage and how to do this with the least effort and physical exertion. Many people have died from starvation because they had failed to take full advantage of a game carcass. They abandoned the carcass on the mistaken theory that they could get more game when needed. If the animal is large, the first impulse is usually to pack the meat to camp. In some cases, it might be easier to move the camp to the meat. A procedure often advocated for transporting the kill is to use the skin as a sled for dragging the meat. When the entire animal is dragged, this method may prove satisfactory only on frozen lakes or rivers or over very smooth snow-covered terrain. In rough or brush-covered country, however, it is generally more difficult to use this method, although it will work. Large mountain animals can sometimes be dragged down a snow-filled gully to the base of the mountain. If meat is the only consideration, and IP do not care about the condition of the skin, mountain game can sometimes be rolled for long distances. Before transporting a whole animal, it should be gutted and the incision closed. Once the bottom of the hill is reached, almost invariably the method is either to backpack the meat to camp, making several trips if no other IP are present, or to pack the camp to the animal. When the weight of the meat proves excessive and moving the camp is not practical, some of the meat could be eaten at the scene. The heart, liver, and kidneys should be eaten as soon as possible to avoid spoilage. Skinning and butchering must be done carefully so that all edible meat can be saved. When the decision is made to discard the skin, a rough job can be done. However, considerations should be given to possible uses of the skin. A square of fresh skin, long enough to reach from the head to the knees, will not weigh much less when it is dried, and is an excellent ground cloth for use under a sleeping bag on frozen ground or snow. The best time to skin and butcher an animal is immediately after the kill. However, if an animal is killed late in the day, it can be gutted immediately and the other work done the next morning. An effort to keep the carcass secure from predators should be made. When preparing meat, all edible fat should be saved. This is especially important in cold climates, as the diet may consist almost entirely of lean meat. Fat must be eaten in order to provide a complete diet. Rabbit meat tends to have very little fat content. Rabbit starvation, also referred to as protein poisoning or mal de caribou, is a form of acute malnutrition caused by excessive consumption of any lean meat, for example, rabbit and birds such as ptarmigan, coupled with a lack of other sources of nutrients in combination with other stressors, such as severe cold or dry environment. Symptoms include diarrhea, headache, fatigue, low blood pressure and heart rate, and a vague discomfort and hunger that can only be satisfied by consumption of fat or carbohydrates. Some early Arctic explorers died after an extended diet consisting only of rabbit meat. The fact that a person will die after an extended diet consisting only of rabbit meat indicates the importance of fat in a primitive diet. The same is true of birds, such as the ptarmigan. Birds should be handled in the same manner as other animals. They should be cleaned after killing and protected from flies. Birds, with the exception of seabirds, should be plucked and cooked with the skin on. Carrion-eating birds, such as vultures, must be boiled for at least 20 minutes to kill parasites before further cooking and eating. Fish-eating birds have a strong, fish oil flavor. This may be lessened by baking them in mud or by skinning them before cooking. There are two general ways to skin animals depending upon the size: the big game method, or the glove skinning method. IP should use the big game method when skinning and butchering large game. The first step in skinning is to turn the animal on its back and with a sharp knife, cut through the skin on a straight line from the tailbone to a point under its neck as illustrated in Figure 1762. In making this cut, pass around the anus and, with great care, press the skin open until the first two fingers can be inserted between the skin and the thin membrane enclosing the entrails. When the fingers can be forced forward, place the blade of the knife between the fingers, blade up, with knife held firmly. While forcing the fingers forward, palm upward, follow with a knife blade, cutting the skin but not cutting the membrane. If the animal is a male, cut the skin parallel to, but not touching, the penis. If the tube leading from the bladder is accidentally cut, a messy job and unclean meat will be the result. If the gall or urine bladders are broken, washing will help clean the meat. Otherwise, it is best not to wash the meat but to allow it to form a protective glaze. On reaching the ribs, it is no longer possible to force the fingers forward, because the skin adheres more strongly to flesh and bone. Furthermore, care is no longer necessary. The cut to point C can be quickly completed by alternately forcing the knife under the skin and lifting it. With the central cut completed, make side cuts consisting of incisions through the skin, running from the central cut up the inside of each leg to the knee and hock joints. Make cuts around the front legs just above the knees and around the hind legs above the hocks. Make the final cross cut at point C, and then cut completely round the neck and then back of the ears. Once the cuts are complete, the IP can begin skinning. After skinning down the animal's side as far as possible, roll the carcass on its side to skin the back. Then spread out the loose skin to prevent the meat from touching the ground and turn the animal on the skin side. Follow the same procedure on the opposite side until the skin is free. In opening the membrane which encloses the entrails, follow the same procedure used in cutting the skin by using the fingers of one hand as a guard for the knife and separating the intestines from the membrane. This thin membrane along the ribs and sides can be cut away in order to see better. Be careful to avoid cutting the intestines or bladder. The large intestine passes through an aperture in the pelvis. This tube must be separated from the bone surrounding it with a knife. Tie a knot in the bladder tube to prevent the escape of urine. With these steps completed, the entrails can be easily disengaged from the back and removed from the carcass. Another method of gutting or field dressing is shown. After gutting is completed, it may be advisable to hang the animal. Note, if it is hot, gut the animal before skinning it. The intestines of a well-conditioned animal are covered with a lace-like layer of fat which can be lifted off and placed on nearby bushes to dry for later use. The gallbladder which is attached to the liver of some animals should be carefully removed. If it should happen to rupture, the bile will taint anything it touches. Be sure to clean the knife if necessary. The kidneys are embedded in the back, forward of the pelvis, and are covered with fat. Running forward from the kidneys on each side of the backbone are two long strips of chopped meat or muscle called tenderloin and or backstrap. Eat this after the liver, heart, and kidneys as it is usually very tender. Edible meat can also be removed from the head, brisket, ribs, backbone, and pelvis. Large animals should be quartered. To do this, cut down between the first and second rib and then sever the backbone with an axe or machete. Cut through the brisket of the front half and then chop lengthwise through the backbone to produce the front quarters. On the rear half, cut through the pelvic bone and lengthwise through the backbone. To make the load lighter and easier to transport, a knife could be used to bone the animal, thereby eliminating the weight of the bones. Butchering is the final step and is simplified for survival purposes. The main purpose is to cut the meat in manageable size portions. Glove skinning is usually performed on small game. The initial cuts are made down the insides of the back legs. The skin is then peeled back so that the hindquarters are bare and the tail is severed. To remove the remaining skin, pull it down over the body in much the same way a pullover sweater is removed. The head and front feet are severed to remove the skin from the body. For one cut skinning of small game, cut across the lower back and insert 2 fingers under each side of the slit. By pulling quickly in opposite directions, the hide will be easily removed. To remove the internal organs, A cut should be made into the abdominal cavity without puncturing the organs. This cut must run from the anus to the neck. There are muscles which connect the internal organs to the trunk, and they must be severed to allow the viscera to be removed. A rabbit may be gutted by using a knifeless method with no mess and little time lost. Squeeze the entrails toward the rear, resulting in a tight bulging abdomen. Raise the rabbit over the head and sling it down hard, striking the forearms against the thighs. The momentum will expel the entrails through a tear in the vent. Save the internal organs such as heart, liver, and kidneys, as they are nutritious. The liver should be checked for any white blotches and discarded if affected, as these indicate tularemia, also known as rabbit fever. The disease is transmitted by rodents but also infects humans. Cold-blooded animals are generally easy to clean and prepare. Snakes and lizards are very similar in taste, and they have similar skin. Like the mammals, the skin and viscera should be removed. The easiest way to do this is to sever the head or legs. In the case of a lizard, peel back enough skin so that it may be grasped securely and simply pull it down the length of the body, turning the skin inside out as it goes. If the skin does not come away easily, a cut down the length of the animal can be made. This will allow the skin to part from the body more easily. The entrails are then removed and the animal is ready to cook. As another option, after gutting the lizard, IP can also char the lizard over a fire, split it down the middle, and eat the meat without skinning first. Except for the larger amphibians such as the bullfrog, the hind legs are the largest portion of the animal worth saving. Remove the hindquarters by cutting through the backbone, leaving the abdomen and upper body. Pull the skin from the legs and they were ready to cook. With the bullfrogs and larger amphibians, the whole body can be eaten. The head, the skin, and viscera should be removed and discarded. Use as bait to catch something else. Most fish need little preparation before they are eaten. Scaling the fish before cooking is not necessary. A cut from the anus to the gills will expose the internal organs, which should be removed. The gills should also be removed before cooking. The black line along the inside of the backbone is the kidney and should be removed by running a thumbnail from the tail to the head. There is some meat on the head and should not be discarded. All birds have feathers which can be removed in two ways, by plucking or by skinning. The gizzard, heart, and liver should be retained. The gizzard should be split open as it contains partially digested food and stones which must be discarded before being eaten. Insects are an excellent food source and they require little or no preparation. The main point to remember is to remove all hard portions such as the hind legs of a grasshopper and the hard wing covers of beetles. The rest is edible. Preparing plant foods can be more involved than preparing animal life. Some plant foods, such as acorns and tree bark, may be bitter because of tannin. These plants will require leaching by chopping up the plant parts and pouring several changes of fresh water over them. This will help wash out the tannin, making the plant more palatable. Other plants such as cassava and green papaya must be cooked before eating to break down the harmful enzymes and chemical crystals within them and make them safe to eat. Plants such as skunk cabbage must undergo this cooking process several times before it is safe to eat. Starchy foods should be cooked since raw starch is difficult to digest. They can be boiled, steamed, roasted, or fried and are eaten plain, or mixed with other wild foods. The maniac, cassava, must be cooked, because the bitter form, green stem, is poisonous when eaten raw. Starch is removed from sago palm, cycads, and other starch-producing trunks by splitting the trunk and pounding the soft, whitish inner parts with a pointed club. This pulp is washed with water and the white sago, pure starch, is drained into a container. It is washed a second time, and then it may be used directly as a flour. One trunk of the sago palm will supply IP starch needs for many weeks. The fiddlehead ferns are the curled, young succulent fronds which have the same food value as cabbage or asparagus. Practically all types of fiddleheads are covered with hair which makes them bitter. The hair can be removed by washing the fiddleheads in water. If fiddleheads are especially bitter, they should be boiled for 10 minutes and then reboiled in fresh water for 30 to 40 minutes. Wild bird eggs or meat may be cooked with the fiddleheads to form a stew. Wild grasses have an abundance of seeds and may be eaten either boiled or roasted after separating the chaff from the seeds, which can be done by rubbing. No known grass is poisonous. If the kernels are still soft and do not have large stiff barbs attached, they may be used for porridge. If brown or black rust is present, the seeds should not be eaten. Ergot poisoning. To gather grass seeds, a cloth can be placed on the ground and the grass heads beaten with sticks. Plants that grow in wet places, along rivers, lakes, and ponds or directly in water, are of potential value as survival food. The succulent underground parts and stems are most frequently eaten. Various members of the calla lily family, which have arrowhead-shaped leaves, often grow in very wet places in the tropics. Jack in the pulpit, calla lily, and sweet flag are members of the arum family. To be eaten, the members of this plant family must be cooked in frequent changes of water to destroy the irritant crystals in the stems. Two kinds of marsh and water plants are the cattail and the water lily. The cattail is found worldwide except in tundra regions of the far north. Cattails can be found in the more moist places in desert areas of all continents as well as in the moist tropic and temperate zones of both hemispheres. The young shoots taste like asparagus. The spikes can be boiled or steamed when green and then eaten. The rootstocks, without the outer covering, are eaten boiled or raw. Cattail roots can be cut into thin strips, dried, and then ground into flour. They are 46% starch, 11% sugar, and the rest is fiber. While the plant is in flower, the yellow pollen is very abundant. This may be mixed with water and made into small cakes and steamed as a substitute for bread. Water lilies grow on all the continents, but principally in southern Asia, Africa, North America, and South America. The two main types are, 1. Temperate water lilies, which produce enormous rootstocks and yellow or white flowers which float on the water. 2. Tropical water lilies, which produce large edible tubers and flowers which are elevated above the water surface. Rootstocks or tubers may be difficult to obtain because of deep water. They are starchy and high in food value. They can be eaten either raw or boiled. Stems may be cooked in a stew. Young seed pods may be sliced and eaten as a vegetable. Seeds may be bitter, but are very nourishing. They may be parched and rubbed between stones as flour. The water lily is considered an important food source by native peoples in many parts of the world. Nuts are very high in nutritional value and usually can be eaten raw. Nuts may be roasted in the fire or roasted by shaking them in a container with hot coals from the fire. They may then be ground to make flour. If IP do not wish to eat a plant or its parts raw, it can be cooked using the same methods used in cooking meat, by boiling, roasting, baking, broiling, or frying. If IP have been able to gather more plant foods than can be eaten, the excess can be preserved in the same manner as animal foods. Plant foods can be dried by wind, air, sun, or fire, with or without smoke. A combination of these methods can also be used. The main object is to remove the moisture. Most wild fruits can be dried. If the plant part is large, such as some tubers, it should be sliced, and then dried. Some type of protection may be necessary to prevent consumption or contamination by insects. Extra fruits or berries can be carried with IP by wrapping them in leaves or moss. A wild game, large insects, freshwater fish, clams, mussels, snails, and crawfish must be thoroughly cooked to kill internal parasites. Mussels and large snails may have to be minced to make them tender. Boiling is the most nutritious, simplest, and safest method of cooking. Numerous containers can be used for boiling, for example, a metal container suspended above, or set beside, a heat source to boil foods. Green bamboo makes an excellent cooking container. Stone boiling is a method of boiling using superheated rocks and a container that holds water but cannot be suspended over an open flame. Examples of these containers are survival kit containers, flying helmet, a hole in the ground lined with waterproof material, or a hollow log. The container is filled with food and water and then heated with super hot stones until the water boils. Stones from a stream or damp area should not be used. The moisture in the stones may turn to steam and cause the stone to explode while the stones are being heated in the fire. The container should be covered and new stones added as the water stops boiling. The rocks can be removed with the aid of a wire secured to the rock before being put into the container or two sticks used in a chopstick fashion. Baking is a good method of cooking as it is slow and is usually done by putting food into a container and cooking it slowly. Baking is often used with various types of ovens. Foods may be wrapped in wet leaves. Avoid using a type of plant that will give an unpleasant flavor to what is being cooked, placed inside a metal container, or they may be packed with mud or clay and placed directly on the coals. Fish and birds packed in mud and baked must not be skinned because the scales, skin, or feathers will come off the animal when the mud or clay is removed. Clam bake style baking is done by heating a number of stones in a fire and allowing the fire to burn down to coals. A layer of wet seaweed or leaves is then placed over the hot rocks. Foods such as mussels and clams in their shells are then placed on the wet seaweed or leaves. More wet seaweed or leaves and soil is used as a cover. When thoroughly steamed in their juices, clam, oyster, and mussel shells will open and may be eaten without further preparation. Clam baking. Any type of food can be cooked in the ground in a rock oven. First, a hole is dug about 2 feet deep and 2 to 3 feet square, depending on the amount of food to be cooked. The sides and bottom are then lined with rock. Next, procure several green trees about 6 inches in diameter and long enough to bridge the hole. Firewood and grass or leaves for insulation should also be gathered. A fire is started in the hole. 2 or 3 green trees are placed over the hole and several rocks are placed on the trees. The fire must be maintained until the green trees burn through. This indicates the fire has burned long enough to thoroughly heat the rocks and the oven is ready. The fallen rocks, fire, and ash are removed from the hole and a thin layer of dirt is spread over the bottom. The insulating material, grass, leaves, moss, etc., is placed over the soil. Then the food, then more insulating material on top and around the food, another thin layer of soil, and the extra hot rocks are placed on top. The hole is then filled with oil up to ground level. Small pieces of meat, steaks, chops, etc., cook in 1.5 to 2 hours and large pieces take 5 to 6 hours. Roasting is less desirable as it involves exposing the food to direct heat which quickly destroys the nutritional properties. Putting a piece of meat on a stick and holding it over the fire is considered roasting. Broiling is the quickest way to prepare fish. A rock broiler may be made by placing a layer of small stones on top of hot coals, and laying the fish on the top. Scaling the fish before cooking is not necessary, and small fish need not be cleaned. Cooked in this manner, fish have a moist and delicious flavor. Crabs and lobsters may also be placed on the stones and broiled. Meat may be cooked by placing it on a flat board or stone planking, which is propped up close to the fire. The meat will have to be turned over at least once to allow thorough cooking. The cooking time depends on how close the meat is to the fire. Frying is by far the least favorable method of preparing food. Nearly all of the natural juices are cooked out of the meat, which tends to make it tough, and some of the nutritional value of the meat will be destroyed. Frying can be done on any non-porous surface which can be heated. Examples are unpainted metal aircraft or vehicle parts, large seashells, flat rocks, and some survival kit parts. Turtle shells can also be considered but are often thought to be too valuable as a helmet to be used for this purpose. Finding natural foods is an uncertain aspect of survival. IP must make the best use of the available food. Food, especially meat, has a tendency to spoil within a short period of time unless it is preserved. There are many ways to preserve food, including cooking, refrigeration, freezing, and dehydration. Cooking will slow down the decomposition of food but will not eliminate it. This is because many bacteria are present which work to break it down. Cooking methods which are the best for immediate consumption, such as boiling, are the least effective for preserving food. Food should be recooked every day until all is consumed. Cooling is an effective method of storing food for short periods of time. Heat tends to accelerate the decomposition process where cooling retards decomposition. The colder food becomes, the less the likelihood of deterioration until freezing, which eliminates decomposition. Cooling devices available to IP include: food items buried in snow will maintain a temperature of approximately 32 degrees Fahrenheit. Food wrapped in waterproof material and placed in streams will remain cool in summer months. Care should be taken to ensure food is secured. Below the Earth's surface, particularly in shady areas or along streams, remains cooler than the surface. A hole may be dug, lined with grass, and covered to form an effective cool storage area similar to a root cellar. When water evaporates, it tends to cool down the surrounding area. Articles of food may be wrapped in an absorbent material such as cotton or burlap and read it as the water evaporates. Once food is frozen, it will not decompose. Food should be frozen in meal-sized portions so refreezing is avoided. Drying removes all moisture and preserves the food. Drying is done by sunning, smoking, or burying it in hot sand. For sun drying, the food should be sliced very thin and placed in direct sunlight. Meat should be cut across the grain to improve tenderness and decrease drying time. If salt is available, it should be added to improve flavor and accelerate the drying process. Smoking is a process done through the use of non-resinous wood such as willow or aspen to produce smoke which adds flavor and dries the meat. A smoke rack is also necessary to contain the smoke. The following are the procedures for drying meat using smoke. 1. Cut meat very thin and across the grain. If meat is warm and difficult to slice thin, cut the meat in 1 or 2 inch cubes and beat it thin with a clean wooden mallet, improvised. 2. Remove fat. 3. Hang the meat on a rack so each piece is separate. 4. Elevate meat no less than 2 feet above coals. 5. Coals are placed in the bottom of a smoke rack with green wood chips on top to produce smoke. The method used to preserve fish through warm weather is similar to that used in preserving other meat. When there is no danger of predatory animals disturbing the fish should be placed on available fabric and allowed to cool during the night. Fish may be dried in the same manner described for smoking meat. To prepare fish for smoking, the heads and backbone are removed and the fish are spread flat on a grill. Thin willow branches with bark removed make skewers. Fish may also be dried in the sun. They can be suspended from branches or spread on hot rocks. When the meat has dried, seawater or salt should be used on the outside, if available. Many animals and insects will devour the IP's food if it is not correctly stored. Protecting food from insects and birds is done by wrapping it in material, wrapping and tying brush around bundle, and finally, wrapping it with another layer of material. This creates dead air space, making it more difficult for insects and birds to get to the food. If the outer layer is wetted, evaporation will also cool the food to some degree. In most cases, if the food is stored several feet off the ground, it will be out of reach of most animals. This can be done by hanging the food or putting it into a cache. If the food is dehydrated, the container must be completely waterproof to prevent reabsorption. Frozen food will remain frozen only if the outside temperature remains below freezing. Burying food is a good way to store as long as scavengers are not in the area to uncover it. Insects and small animals should also be remembered when burying the food. Food should never be stored in the shelter as this may attract wild animals and could be hazardous to IP. Thank you for watching.
Von Sprachversagen, denn seine Sprache ist dahin. Ich kann nichts tun, als dich beklagen, weil ich zu schwach zu helfen bin. Ich kann nichts tun, als dich beklagen, weil ich zu schwach zu helfen bin. Weil ich zu schwach zu helfen bin, weil ich zu schwach zu helfen bin. Die Königin begnadigt dich, entlässt die Strafe durch mich. Nun plaudert holdet Papageno wieder.
Applaudere, lüge nur nicht wieder.
Ich lüge nimmer mehr, nein, nein.
Dies Schloss soll deine Wohnung sein.
Dies Schloss soll meine Wahl
Soll
sein.
deine Wahl
Soll
sein.
meine Wahl sein.
Bekämen doch die Lügner alle ein solches Schloss vor ihrem Mund.
Schafft aus, Erneugung schwarzer Galle.
Bestünde niemand Bruder und
Schafft aus, Erneugung schwarzer Galle.
bestünde niemand Bruder und Prinz, nimm dies Geschenk von mir, dies segnet unser Fürst in dir. Die Zauberflöte will dich schützen, im größten Unglück unterstützen. Wie wild kannst du allmächtig handeln, der Menschen Leidenschaft verwandeln, der Traurige wird freudig sein, denn alle Stolz mit Liebe ein. So eine Flöte ist mehr als Gold und Kronen wird, denn durch sie wird Menschenglück und Zufriedenheit verwehrt. Wird Menschenglück vermehrt, Zufriedenheit vermehrt.
Nun, ihr schönen Frauenzimmer, darf ich, so empfehl ich mich,
Dich empfehlen kannst du immer, doch bestimmt die Fürstin dich, mit dem Prinzen unverweinen, nach Sarastos Burg zu eilen.
nein, dafür bedank ich mich. Von euch selbsten hörte ich, dass ihr wie ein Tigertier sich ließ ohne alle Gnade mit Rast rufen, braten, setzte mich den Hunden hier.
Die schönste Prinzfrau im Allen, dafür sollst du sein Diener sein.
Dass doch der Prinz mein Teufel wäre, mein Leben ist mir lieb. Am Ende schleicht bei meiner Ehre er von mir wie ein Dieb.
Hier nimm dies Kleinod, es ist dein.
Ei, ei, was mag da drinnen sein?
Darin wirst du Glöckchen tönen.
Werd ich sie auch wohl spielen können?
Oh, ganz gewiss, ja, gewiss. Silberglöckchen, Zauberflöte, sind zu unser Schutz vonnöten. Lebet wohl, wir wollen gehen. Lebet wohl, auf Wiedersehen. Lebet wohl, auf Wiedersehen.
Doch schöne Damen, saget mal, wo man die Burg wohl finden kann. Wo man die Burg wohl finden kann, wo man die Burg wohl finden kann.